Section 1.3. As we go through a lot of these sections, we're learning little building blocks that we can use later. And this is definitely one of those that we're going to be using later because we're going to work with these imaginary numbers quite a bit. And an imaginary number is actually part of a complex number. Imaginary number is actually part of a complex number. You're going to see that as we go through this section. So let's knock the rest off imaginary numbers. Way back when you learned we can't take the square root of a negative. The reason why is if I graph y equals the square root of x, it looks like this. It starts at 0 and runs up in the first quadrant, slowly growing and growing and growing. But I can't take the square root of a negative. But we don't want math to end. So what we've done is say, we're going to make the square of -1, and we're going to call it I. Okay? And if I have the square root of -1 times the square root of -1, I would get I squared. Definitely, 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 definitely important. Okay, so I'm going to get ready, and I want to take the square root of -100. And Stephanie's back. Stephanie, you're here.
Yes, hi, sorry.
Yay, you missed Tuesday.
I know, I was at the airport. I'm sorry.
Oh, sure, must be not. I know, I'm jealous. I'm jealous. Okay, so an imaginary number, right? First part of a complex number. First example I'm going to take a look at is -100, and it says in the directions to simplify. But I remember back to when I would have something like the square root of 50, I was allowed to write that as the square root of 2 times the square root of 25. And I was allowed to write that as the square root of 2 square root of 25. I was allowed to break those apart. And the reason I broke those apart is I can simplify this because 25 is a factor of 50, but it's also a perfect square. And I can take the square root of that. And this would now give me 5 square root of 2. 5 square root of 2. So I'm allowed to break up a product into separate. I'm allowed to take this first one and break up a product into 2 separates. -1 square root of 100. That becomes I. That becomes 10. And hopefully some of you are going, oh yeah, Kool-Aid here. Oh yeah, I remember how to do this. So I'm going to pause the computer. I'm going to give you about 3 minutes to work on some of these problems and see how far you get, and then we'll catch up, and then I'll give you some time. But I think these are good mental exercises for you to be trying before I go over them. Okay, I'm going to pause the video or the recording. Okay, so we're back to the video. Those of you that are watching the video, you'll be like, oh, that was a short break. It was a little longer than that. I didn't want to give you too much time in case you were going in the wrong direction. But taking a look at a couple of these, number 2, I calculated the answer to be 6i. Number 3, I square root of 6. Number 4, square root of 21i. Now you may notice that there's a bug on my paper. No, ain't no bug no more. You may notice that in one case I put the I in the front, in one case I put the I in the back, and it really doesn't matter. But probably Alex wants you to do it with the I at the end. So I wrote it as 2 different to show you. Go ahead, Maria.
Yes, I was about to say that Alex does. I try and doesn't agree with it.
Yeah.
You have to change it, even though the actual information is different. The placement is completely different. They don't let you.
Right, right. So let's just get in the habit of that, putting the I at the end. And even for this one, I should have put 5 square root of 2i. For this one, I should have put 4 square root of 3i, -4i. Are there any questions on the first 7? Jump right in, unmute, and jump in. Okay, excellent. Well, I had a chance and I was able to work ahead. I was able to do 8, 9, and 10. And remember I said we can break those radicals, those square roots apart. We can put them back together, different things. Here I have 2i times 5i, which is 10i squared. And one of the things from the very beginning of this section at the top of this page, I mentioned that I squared equals -1. So all this work simplifies down to just -10. Cool beans. All of this work, I pull the I out, I pull the I out. Instead of multiplying the negatives together, that causes a problem because that would end up giving me an answer of +20. I don't want +20. I handle the I's first. Handle the I first. Now I can do some work. Here's a 2, because this was 2, or excuse me, 4 times 10, which I pulled the 2 out. Square root of blah times the square root of blah equals blah. That's where the 10 comes from. Say that again. Square root of blah times the square root of blah is the square root of blah squared. And the square root and the square cancel, and we're left with just blah. Blah. I always wanted to be a vampire. Blah. Can handle the I first. Get the I out. 98 is 2 times 49, or 7 squared of 2. Nice. There you go. Final answer, 7i. Questions? Doing a lot of problems today. Maria.
Yes, this is a case of one of the positive plus positive equal negative, and negative plus positive equals what? That will be.
Which problem are you talking about here?
No, I'm just trying to, in general, into the whole problem. Like, it's just a case how you place the numbers. Sometimes it's like how you place the imaginary number.
Right. Yep.
I'm trying to like figure it out.
Yep. And that's up here. That's a good example of it. And everything's multiplying. Okay. Yeah, lots of different learning styles, that's for sure. Now, the imaginary number, that's part of what this thing is called as a complex number. And you can see out here, there's an imaginary part. And it's a number with the I on. But a complex number is always this form of A, which is a real number part, and BI, which is the imaginary part. So if I start taking a look at some of these, I say, oh, this is -5 plus 0i. Complex number. It's a real part and it's an imaginary part. This one's a real part, 0 plus 17i. And we don't do much with it, but it's just to show that everything can be written as a complex number. Hopefully you got excited and went 5 minus 2 squared of 3i. This is -1 times 4 times 3. The square root of -1 is the I. The square root of 4 is 2. And it leaves my 3 inside. Nice. And we always circle our answers. Well, to make number 14 a complex number, we write it as 6/3 plus 5i/3. And we go, okay, that's going to be 2 plus 5i/3. Ta-ta, a real part and an imaginary part. a real part and an imaginary part. -1/5. This becomes -1 times 4 times 2. So that becomes square root of 4 is 2. Square root of 2 stays. Square root of -1 is I over 10. And if I wanted, I could simplify that as well. -1/5 plus square root of 2i. 2 and 10 is 5. Nice. Whoa. I had to tell my Math 104 class yesterday, remind me if I'm going too fast. Tell me to slow down. This stuff excites me, especially because I know how to do it. If you know how to do something, it does in fact excite you. All right, there's a bunch down here. I don't need you. I need you to remember that I squared is -1. Don't worry about the rest of these. They're just goofy and not something we would really ever use. Okay, but I squared is -1. All right. So we started with imaginary, then we expanded it to complex. Now we're going to get into adding, subtracting, multiplying, and dividing complex numbers. I'm going to pause the recording and give you a couple minutes and see how far you can get without my help.
Not New York. They was born in Queens.
This meeting
and
is
one in the
being
Bronx.
recorded.
Okay, let's see what we have. Any questions on 19? I added the real parts. I added the imaginary parts. Please let me know if I messed this up, if you have something different, because there's chances I could be, yeah, oh boy. 8 minus a negative is like adding 2. So that becomes 10 and 4i. Okay, now we get into some operations other than adding and subtracting. We're going to multiply. -12i plus 8i squared. That becomes a -1. And then I write it in complex number form. Ba-boom. Starting to get harder here with 21. The next one, you guys know this as FOIL, a binomial. I call it double distribute. I distribute to 4, I distribute to 2i. Then I distribute to -5i, and one more time. I double distribute. Sometimes these are more than binomials, and it's good to think that way. 4 times 3 is 12. 8i minus 15i minus 10i squared. Okay. Let's see. This is 12 minus 7i, and that becomes plus 10. 22 minus 7i. Oh. Okay. 6 minus 7i squared. I know that means multiply it by itself. That doesn't mean distribute it to. Yeah, no. Right? I'm multiplying it by itself. I'm double distributing again. 6 times 6. 6 times -7i. -7i times 6. And yep, I got that. Minus 49. Boom. Again, let me know if I'm going too fast. I don't want you to be in a mode that you're just copying. Hopefully you're a little bit ahead and keeping an eye on what I'm doing. This is a good one. This number 24, this is a gooder. When I do this multiplication, I have something that's called the product, because I'm multiplying, the product of a sum and a difference. The product of a sum and a difference. And this guy is related to the first one. It has a name, it's called the conjugate. The second one is related to the first one, it's called its conjugate. Because watch what happens when I double distribute. I get 4 plus 10i minus 10i minus 25. That becomes 4. Shazam, 10i minus 10i, gone. This becomes a negative, gives me a plus 25. I get 29. So when I multiplied something by its conjugate, the imaginary is gone. Nice. Nice.
So the I squared just cancels?
This I squared becomes -1 times -25. So this actually starts to look at -25 times -1.
Okay,
And that gives me now a positive.
that
So
positive
yeah,
25.
that I squared basically changed the sign out front. Is a way
Okay.
to think of it.
So do you want us to put the plus 0i at the end or not?
Nah,
Okay.
nah. Good question. And I don't think Alex wants it either. It might, it'd say, please write, if it says, please write in complex form, then you would put 0i, but I don't think that's gonna happen if it does at all. Hey, Professor, I'm having trouble finding the worksheet that you were currently working on. On D2L, under the news. D2L under the news. Okay. So one of the things I know from the math world is I can't have 4 over the square root of 2. Somewhere along the line, you've learned that you cannot have a square root in the denominator. And when I look at problem 25, I see an I in the denominator, and I'm not allowed to have that. So I need to get rid of it and simplify it so I can write it in the form of A plus BI. Well, 3 minutes ago, we just looked at multiplying this by something to get rid of the I. Well, I'm going to multiply by 1, which means whatever I multiply the bottom by, I need to multiply the top by. So what would you like to multiply the top and the bottom by? C word. C word. Conjugate. Yes, the conjugate. So I'm going to look down here because this is the one I want to use. Its conjugate. So I'm going to multiply by 2 minus 6i and 2 minus 6i. I'm looking ahead. I got excited. I'm going to multiply by 1 plus 3i and 1 plus 3i. Yeah. Going to do that double distribute.
You wrote 2 minus 2i for 25.
Crappers. Where? I don't see it. I have 2 minus 6i.
Yeah, me neither.
Yeah, thank you. Thank you. Well, let's not get too far ahead of ourselves. Let's get back to work up here. Double distribute. I'm going to have in my numerator a -4 plus 12i plus 14i minus 42i. You know what? That was my first mess up of the day. That was pretty good for me. I made it an hour and only goofed up once. Small victories. In the denominator.
You got it again.
Did I mess up again?
It's I squared at the end.
Ah! Should have kept my big fat mouth shut. Thank you. 4 minus 12i plus 12i, and that's why we multiplied by the conjugate, minus 36i squared. Again, you're going to be doing problems in a month from now, and you're going to get something in the denominator, and you're going to go boom, conjugate. This will be the second or the third part of a problem that you'll be solving, because we're going to keep building and building and building. Okay, -4 plus 16i plus 42. 4 adios plus 36. That's going to give me 38 plus 16i. You're distracting me. Don't put that up there. Over 40. 38 over 40 plus 16i over 40. That's about 19 over 20. Again, I'm going quickly. 8 over 20. Oh, yeah, I divide both of those by 4. I over 10. Ha 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 ha. It's a bit of work on that problem.
Question.
19, divided 38 and 40 by 2.
I got a-
divided by 2. Yeah, question.
You did 16i on the top, but 12i plus 14i, that's 28, right?
Me and my big mouth, that is in fact 28.
So it was 13 over 20. Oh,
Becomes-
It's 26.
26.
Not 20.
It's
Oh,
13 over
goodness gracious.
20 plus 13 over 20.
All right, so we're there, right? 38 plus 26i. Goodness gracious. Yeah, I know, I got jinxed somehow. So let's not look at any of that. 38 over 40 plus 26i over 40. Oh my goodness. Divide both of those by 2. Divide top and bottom by 2. 13i over 20. Oh my goodness. Jeez. Can we redeem ourselves with number 26? Or yeah, can we redeem ourselves?
That's correct. I have 19 over 20 plus 13i over 20.
All right, good. I wasn't really gonna move on until somebody checked. Good to know. We're not doing 28, by the way, so if you want to go down and cross that one out, that's fine. Well, let's see if I can get this one right. Here we go. 1 plus 3i minus 8i minus 24i squared. Good, I got the first part. I shouldn't say anything. 1 plus 3i minus 3i minus 9i squared. I'm going to pause. I'm going to say, are we okay with that? Okay.
Can you actually go over how you got all that? I'm sorry.
Yep, I'm going to double distribute. So I'm going to take 1 times 1. I got 1. I'm going to take 1 times 3i. That gives me the 3i. Now I take negative 8 times 1. Or excuse me, negative 8i times 1. That's that. And negative 8i times positive 3i gives me negative 24i squared.
Okay, thank you.
Mhm. And again, I like to call it double distribute. Some of you call it FOIL. Do the same for the denominator, but now in the numerator, I get 1 minus 5i plus 24 over 1 plus 9. The 3i and the negative 3i, they're going. I squared becomes -1, which turns this into a plus 9. 25 minus 5i over 10. Five hands minus I over 2. Please tell me I redeemed myself and I got that one right.
Looks right.
Small victory, woohoo! Everybody should go into the reactions and do a hand clap or fireworks or a horn or something like that. Yeah, everybody clap your hands, clap, clap, clap your hands. Okay. Do I have a conjugate for number 27? No. What can I multiply it by? Well, I can do this one really easy. I'm going to multiply top and bottom by I. Because in the denominator, I'm going to have 4i squared, which is going to give me -4. So I only need an I to clear it there. Oh, good. 4i minus 3i squared. That becomes a positive 3. And